This is quick revision of semester 3 chemistry. First, I'll start with inorganic chemistry. In that, first important theory in the sense, this video only for students who want to get pass marks. Okay. This is first theory, important Werner's theory. In that, remember three important points: primary valency, secondary valency, and cobalt amine structures. These are the cobalt structures. Practice one time. Is the only structures. You can draw in the exam. This is Werner's theory. Next, Sidgwick's theory means, remember, that is EAN rule, effective atomic number. Sidgwick's theory, note important points: Lewis acid, metal Lewis acid, ligand Lewis base. Okay, and EAN rule. Formula, remember, effective atomic number means atomic number minus oxidation number plus 2 into coordination number. Remember the formula and one example. Practice one example. Okay. Next, valence bond theory. Valence bond theory means it is related to hybridization. sp d orbitals hybridization takes place, and you will get d2sp3 or sp3d2. Inner means if d2 is inside, that is inner orbital. If sp3d2 means d orbital is outside, 4d orbitals involved, that is outer orbital. Remember that points. You remember hybridization concept. Okay, hybridization concept and inner orbital, outer orbital complexes, and magnetic property. Remember these 3 points. That is valence bond theory. And practice one example for valence bond theory: iron complex or cobalt complex. Practice one time. Next, isomerism concept. Isomerism means here you have two different isomerism: structural, stereo. Structural ionization, linkage, coordination, ligand. For this, you practice examples. Ionization means different types of ions. Linkage means linkage is different. Coordination ligand means complete coordination complex is different. That is structural. Stereoisomerism. In stereo, geometrical, optical. Geometrical means cis and trans. Practice examples. These examples: cis means adjacent, trans means opposite. Okay, remember the example and practice one time. Geometrical isomerism present in coordination number 4, coordination number 6. Okay. Next, optical isomerism, coordination number 4, tetrahedral. Practice this example. Otherwise, you can leave this question. Okay. Optical isomerism in coordination number 6. This is D isomerism, L isomerism. Practice this example one time. That is isomerism concept. Nomenclature simple only. Just you practice this examples. Practice this one. Practice the names. Remember the names of ligands. Next, F black elements. Next lesson is F black elements. We read only 2 questions. This is F black element series. 14 F black elements are present. If you have time, remember this names and electronic configuration. Otherwise, you can leave this one. Contraction. This is lanthanide contraction. Decrease in the size. Lanthanide contraction. Question is important. And what are the reasons for lanthanide contraction? Next, concepts. What will happen if lanthanide contraction takes place? Okay, remember these points: occurrence of yttrium with heavier lanthanide, basicity difference, anomalous behavior of post lanthanides. At least remember the headings. Okay, no need to practice all this one. Remember the headings. Okay, color properties, magnetic properties. For magnetic properties, at least remember this formula. Next, complex formation. This is not separation of lanthanides. This question is important. How to separate different types of lanthanides? One method is ion exchange method. Another method is solvent extraction method. By using different solvents, you can extract the required lanthanides. That is separation of lanthanide. Which type of chemicals are used for solvent extraction? This is the matter. Just read once. Next, difference between lanthanides and actinides. Lanthanide means 4F, actinide means 5F. There is some differences. You can read this question easily. Next, differences between D black elements and F black elements. Okay, there are differences. You can read that one. Next lesson is metal carbonyls. In metal carbonyls classification, mononuclear means only one metal is present. Polynuclear means 2 or 3 or more than 2 metals are present. Here Mn2, Fe3 like that. 18 valency electron rule is also important in that one. Metal carbonyls generally follows 18 valence electron rule. 18 valence electrons present in metal. That is 18 valence electron rule. Here are some examples: nickel CO4, FeCO5, CrCO6. These are all having 18 valence electron. In valency shell, the number of electrons are 18 in complex. Next, remember this preparation and properties of nickel. Nickel tetracarbonyl. Easy only. Preparation. Property means just opposite that one. Here this is the property. Next, structures. Compulsory practice these structures. Nickel CO4 structure. Easy only. Nickel middle CO tetrahedral shape. Next, CrCO6. This is called octahedral shape. Okay, practice one time. Next, FeCO5. Trigonal bipyramidal shape. Fe2CO9, Fe3CO12. Okay, these molecules present in your syllabus. All molecules practice one time. That is about metal carbonyls. In metal carbonyls, we have one more topic also, that is organometallic chemistry. Organometallic chemistry classification and examples: ionic, sigma bond, pi bond, alkyl, bridged. At least remember one example for ionic, covalent, okay, bridged. Remember one example. This question is important. Grignard reagent preparation properties. Preparation properties. Preparation properties. These properties are for Grignard reagent and alkyl lithium. For both, properties are same. Properties means reactions. Okay, same. That is complete inorganic chemistry. Organic chemistry, first you finish general chemistry. Inorganic, then general. After that, if you have time, read this one, organic. Inorganic, at least read this esterification reaction and mechanism. Esterification reaction and mechanism. Just opposite to that one, ester hydrolysis. This question is also important. Opposite. If you read this one, just opposite reaction is ester hydrolysis. Okay, at least in organic you read this one. Okay, these are all reactions only in organic. If you have time, at least practice the only reactions. Hunsaker reaction, Schmidt reaction. At least the reaction you practice. Leave the mechanism. Only reactions. Untested reactions. HVZ reaction. These all are reactions of carboxylic acid. Carboxylic acid derivatives. This reaction is important. Hoffman bromamide reaction. And mechanism also important for this one. Mechanism is also important. Next, you can leave this one. Gabriel synthesis. For pass marks, you can leave. Basicity of amines important question. Basicity of amines order. Remember this order: secondary greater than primary, greater than tertiary, then ammonia. Aromatic amines basicity is also important. Next, Hinsberg separation. How amines are separated by using Hinsberg reagent. Okay, this question is also important. This is a flow chart. If you see this one, you can understand how amines are separated. Next, alkyl cyanide, isocyanide. If you have time, you can read this one. Easy only. If you compare alkyl cyanide, isocyanide, easily you can attempt this question. Easy question from organic, you can easily attempt this one. Next, benzene diazonic chloride. At least remember the reaction. BDC salt. Leave the mechanism. At least read the reaction. This is also simple only. Coupling reactions. All reactions. These are the benzene diazonic chloride reactions. You can leave this one. Nitro compounds. In nitro compounds, at least read Tatomers of nitro compounds. And Neff reaction. Remember, Neff reaction is very important. Conversion of nitroalkanes to aldehydes or ketones. That is Neff reaction. Read that question. Next, this is not important. Preparation of carboxylic acid. This is complete syllabus. To get pass marks, only read important questions. What I have said, read that one. Phase transfer catalyst, and that is inorganic. You read just esterification, ester hydrolysis, Heinsberg separation, Hoffman bromide reaction, cyanides, isocyanates, and B.Sc of amines. Read that questions. In physical chemistry also, read first. Only I have given 10 to 11 questions. First law of thermodynamics important, compulsory. This equation and diagram, write this one. First law of thermodynamics important. Derivation is also important. Otherwise, at least remember the last equation. Problems are asked from this equation. So that's why at least remember this one. Enthalpy. This derivation is important. Cp minus Cv is equal to R. Next, Joule-Thomson effect. This easily you can attempt in the Joule-Thomson effect. Next, Carnot cycle. Carnot cycle question is very important in thermodynamics topic, physical chemistry. In physical chemistry, only you have thermodynamics topic. At least practice these diagrams. Okay, diagram and these equations. Practice all equations are same only, similar. If you practice, you can get the marks. Next, second law of thermodynamics. This is read this entropy question. Entropy, what is entropy? Disorderness, measure of disorderness. Remember this formula, delta S is equal to Q by T. Next, entropy change. Okay, you can leave this one. Gibbs free energy, Gibbs Helmholtz equation. At least remember these final equations. Kirchhoff equation also. If you have time, practice this one. Otherwise, at least remember the equations. You will get 1 to 2 marks. This is a problem. This is another problem regarding work done. Okay, these model questions. Next, intensive, extensive property. This question is also important. General only. State function, path function. Next, Maxwell equations. Maxwell equations important. Final topic is general chemistry. First unit 1, then read unit 4. After that unit 2, unit 3. Okay, general chemistry very easy. In general chemistry, first finish this topic, errors. General topic only. Don't leave this lesson. Errors, absolute error, relative error, classification of errors, determinate, indeterminate errors. Okay, indeterminate class, another classification. Personal, instrument, methodic, operational. Here theory is also there. Don't leave this one. That is error topic. See what is accuracy, precision. Okay, from this diagram you can write the matter, and I have given examples also. Significant figures. This question is also important. What are significant figures? What are not significant? Okay, here some rules are there. I have given examples also. From this, they are giving some figures, and they are asking to write significant figures. Please check the previous question paper if you have any doubts. Next one is these are the significant figures rules. Mean, median, range, standard deviation. These are the problems. Next, carbon ion lesson. In carbon ion lesson, you read this one. Tatomerism question is important. You read this one, aldol condensation reaction, benzoin condensation reaction, and mechanism also important. Perkin reaction, haloform reaction. These 4 reactions are important. 4 reactions. You practice 4 reactions. In carbon ion lesson, at least practice that 4 reactions. Phase rule topic. This is also very important. Last topic, phase rule. Definitions of phase, example. Definitions of component and examples. Definition of degree of freedom and example. Water system. First to practice this diagram. From that diagram, in phase rule, what you have to do, you have to find F, degree of freedom, for curves, areas, and triple point. Okay, here the diagram contains curves, triple point, areas, and your aim is to find out the F value by substituting component is one, phases by substituting different phases. Okay, all areas same only, AOC, BOC, like that. In all areas you will get F is equal to 2. Remember, area 2. In curves, F is equal to 1. At triple point, F is equal to 0. Compulsory, you practice this question compulsory. Water phase diagram and silver lead phase diagram. That is, water is one component, this is two component system, and phase is also different. That is, F is equal to C minus B plus 2 for water. For this, F is equal to C minus B plus 1. Don't forget, there is a difference. And this is a phase diagram of silver lead. That phase diagrams two are different. For water that is different, silver also, lead silver also different. Next, okay, this is the phase rule. Desilverization of lead or Pattinson process. Short question. Congruent melting point, magnesium zinc system. For that, at least you practice this diagram, magnesium zinc. Okay, easy only diagram. Magnesium zinc, congruent melting point, incongruent melting point. Example is salt water. Okay, this is a diagram. This is diagram for salt water. Okay, this is complete phase diagram. Okay, first complete unit 1, unit 4 to get pass marks. Unit 1, unit 4. If you have time, read organic, that is esterification, ester hydrolysis, Hoffman bromamide. Okay, and that separation of amines, basicity of amines. After that, read first law of thermodynamics, second law of thermodynamics. Remember the formulas of Carnot cycle, work done. Remember that formulas, at least remember that formulas. Okay, this is Sem 3 chemistry important questions explanation.